Hi everyone, welcome to this video. We are going to look at two SRM questions, okay? Statistics for risk modeling, one of the Society of Actuaries exams, okay? Okay, good. So these questions, there are two of them here. I picked them up from the sample questions which are available on the SOA website, okay? The SOA website. So again, SRM, yeah, statistics for risk modeling. This is question number 11. Let's breeze through it. You're given the following results from a regression model. Okay, and if you look at the question here, you're asked to calculate the sum of squared errors. Okay, what are we given? We are given the observed value. Okay, we're given the observed value, and we're given the fitted value. Okay, the fitted value or the predicted value. Okay, so you want to find the sum of squared errors. Well, sum obviously we need to, it can't get any easier than this, right? It's pretty easy. So you just take your observed value minus your predicted value, okay? Square it, okay? 5 minus 3, let me write slowly, square it. And then I have got my 6 minus 9, let me square it. 8 minus 3, let me square it. And 4 minus 6. So we are getting, this will be 4, this will be 4, this will be 9, this will be 25, and this will be 4. So I've got 4 plus 4 plus 4, 12. 12 plus 9 is 21. And 21 plus 25 will be, the sum will be, 21 plus 25 will be 46. So let's go ahead and look at the correct response that we need. So the correct response will be great, E. Okay, so I've done the working here. This is pretty easy, right? As a question for an SOA exam, it's pretty easy. So let's move on, right? The correct answer is E, 46. So now I can erase this. Let's move on, okay? Next question. The next question, let's read it slowly. Yeah? The next question is question number 23. So you can look this question up on the SOA website, yeah, on the SRM sample questions PDF. We have got Toby, right, observes the following coffee prices in his company cafeteria. The prices are 12 ounces for $1, 16 ounces for $1.20, and 20 ounces for $1.40. Okay, great. The cafeteria announces that they will begin to sell any amount of coffee for a price that is the value predicted by a simple linear regression using least squares of the current prices on size. Okay, great. Let me just move this up a little bit. Toby and his co-worker Karen want to determine how much they would save each day using the new pricing if instead of each buying a 24-ounce coffee, they bought a 48-ounce coffee and shared it. Okay, so be careful about a few things. First off, make sure that you read the question carefully. So let me make some comments here. Okay, read carefully the question. And they've given me some data here. So we have got the explanatory variable and the response variable. So let's go ahead and write those out first. I've written it out in my solution, but let's just go ahead and do it, right? Let's write down the explanatory variable. We have got 12, 16, and 20. And the response variable, we have 1, 1.2, and 1.4. Great. So they tell you that they will begin to sell any amount of coffee for a price that is the value predicted by simple linear regression using least squares of the current prices on size. Great. this person, Toby, and the co-worker, they want to determine how much they would save, how much they would save each day using the new pricing if instead of each buying a 24 ounce, they bought a 48 and shared it. Okay, 48 ounce and shared it. Okay, great. So with this data in mind, or what they've given us, what we can do is we can go ahead and work out your regression equation, right? So we have y hat equals to beta naught hat plus beta 1 hat x. Okay, so I've got y hat equals to beta naught hat plus beta 1 hat times x. So what we can do, right, before doing any other calculations, you can plug all these numbers into your calculator. Okay, plug all these numbers into your calculator, and then you can get out the values of beta naught hat and beta 1 hat. Okay, the slope and the intercept. So I repeat, just plug all these numbers into your calculator, and you can get the values of beta naught hat and beta 1 hat. So if you do that, right, if you do that, you will get, let me show you what I got, right? If you do that, you'll get y hat equals to 0.4. Let me clear this, yeah? Okay, you'll get y hat equals to 0.4 plus 0.05x. So you'll get a regression equation, right? Just use your calculator, plug in the numbers, and you'll get this. So now, let's go ahead and deal with a 24 ounce. So when you plug in x equals to 24, okay, when you plug in x equals to 24 into your calculator, you'll get 0.4 plus 0.05 times 24, okay, you'll get 1.6, okay? And remember, you're going to buy, they're each buying a 24-ounce coffee, so we have to multiply by 2, right? So you multiply by 2, so they're spending 3.2. Okay, great. So they're spending 3.2. What happens if they bought a 48 and shared it? So which means they're only buying one, right? So you plug in 48, okay, plug in 48 here, and you'll get your y hat equals to 2.8. So which means if you buy a 48 ounce coffee, you're going to pay 2.8. And if you buy two 24 ounce coffees, then you are going to pay 3.2. So by sharing a 48, let me just move that up. Okay, good. Okay, so by sharing a 48 ounce coffee, you are saving. Let me just get rid of this. Okay. Okay. Give me a second. Okay, good. So you are saving 3.2 minus 3.2 minus 2.8, you'll get 0.4. So your correct response will be C. They would save 0.4. Not difficult, right? Because it is just numbers that you plug into your calculator to get the regression equation. Y hat equals to 0.4 plus 0.25x. Plug in the value of 24, you'll get 1.6. Remember, when you buy the 24 ounce, you are going to multiply by 2. So you're going to spend like 3.2. And then for the 48 ounce, we're only going to buy one. You're going to spend 2.8. Okay. And so the difference, 3.2 minus 2.8 is just 0.4. So they have a saving of 0.4. Pretty easy to do. Okay. Alternatively, you can go ahead and, use your formulas that you have learned. Okay. Let me just write it down here. You can use these formulas. Okay. And then work out all these, if I may call it sum of squares. Actually, they are not exactly sum of squares, SXY and SXX, but let's just call it sum of squares. Okay. So you can use these formulas and work out your beta 1 hat, and then you can get your beta naught hat, okay, by using your y bar minus your beta 1 hat x bar. Okay, all these numbers you can easily get because y bar is just, you sum all the y values and you divide by the number of values, and x bar is the same thing. Sum all the values and divide by the number of values you have, average, right? So you can get those numbers using these formulas as well. Now, the other thing that I want to make a remark is you could have done this maybe, I'm not sure how much time you will save, but if you recognize that these points lie on a straight line, okay, if you recognize that these points lie on a straight line, these XY points, right? 12, 1, 16, 1.2, and 20, 1.4. I'm talking about these points, right? Okay, I'm talking about these points here. If you recognize that they lie on a straight line, you can go and write the equation of the straight line straight away. So I've attempted to do that to give an idea of an alternative way on how to solve this problem. Okay, by finding the gradient and stuff like that, you'll get the same equation, 0.05x plus 0.4, and then you can go ahead and plug in the value of 224 and the value of 48 and so on, and still get the same answer. The saving is again 0.4. Answer C. Okay, thank you very much for watching. I will let me make a remark. I will be looking at more questions in SRM over the next few weeks. And as I look through them and work some solutions, I will post some videos. Thank you for watching.